Good morning, everybody. Hopefully everyone's doing well. Today, looks like we have a smaller turnout. That's okay. The important ones are here, right? If you could go with green check mark, make sure everyone can hear me and everything's working good, and then we'll get going. Perfect. A few of you chiming in. I have like all morning here to do anything you guys want in terms of going over work. So if you would like to go through some more stuff off of the learning guide, we can do that. Or I can continue to go through that provincial exam that I had uploaded yesterday. We can do that as well. So, I mean, if you had any questions at all, you want to put them in, that would be good. If not, I'll just kind of go through the provincial exam. And if there was specific questions from any of the previous material that we haven't seen for a long time and you're just like a little bit unsure of anything, let me know and we can find it. Ava, I'm assuming that is referring to page 9 of the final exam, or if it's midterm number 2 review. And then page 2, 4A. Okay, so we're talking about a couple different things here, but I think I know what everyone's implying. Okay, good. All 4 and 5, page 3 of the Unit 8 Learning Guide. So Alex, maybe I'll jump into your question first, and then I'll go to the midterm learning guide, and then we'll go over Ava and Taylor's questions, and then we'll see where we're at. All right, so Unit 8 Learning Guide, page 3 you mentioned, I believe. Getting all confused now. Page 4 or 5, page 3. Okay. Holy cow, got a big mess here. Given the following information, find the unknown side to the nearest tenth. So these two questions are really similar in that one, you're just trying to find the unknown thing on a triangle. And you need to, first and foremost, when you do any of these questions, is identify what angle you're dealing with. Before you do any trig question, you need to identify the angle. So in this number 4, you're dealing with this angle in the corner here. It's asking us to find this side, which is the longest side in my triangle, so it's going to be the hypotenuse. And then I have 2 other sides, the opposite and the adjacent. So if I started at this angle, I go straight across to the other side. That makes this the opposite. And then this is the adjacent. And I'm, in this question, not using the adjacent. I'm not trying to find it, and it's not given. So I'm dealing with the opposite and the hypotenuse. So Katoa says that if I'm dealing with the opposite and the hypotenuse, that's going to be the sine function, because sine has the opposite and sine has the hypotenuse in it. So I'm going to use that. So the sine of my angle, whatever it is going to be the length of the opposite side divided by the length of the hypotenuse. And in this case, the angle is 42 degrees. The opposite side is 6, and the hypotenuse is x. No problem, Avery. Glad you're here. All right, so I just need to solve for x, get it by itself. I might as well show the steps. I have x on the bottom, so I want to get it to the top. I'm going to multiply both sides by x, because on the right side, the x and the x are going to divide to give me 1, and then I'm going to have x times the sine of 42 on the left side, which equals 6. And then I want to get the sine of 42. Remember the sine 42, I can treat it like a decimal number, because that's what it is. It's a ratio of sides. Here it's going to divide out and give me 1, and I'm left with x is 6 divided by the sine of 42 degrees. And from here I can just plug this into my calculator. 6 divided by sine 42. I don't remember what I had up there, so I'll just do it again. and I get 8.96668. So we'll go 8 point. Oh, I think Abby asked about this one because it was a weird one in the rounding. So we had 8.9668. And then it asks us to round to the nearest tenth, but our tenth is a 9, so if we round the 9 up, then we have to round the 8 up, and then we end up with 9.0 once everything's kind of been rounded, which is just kind of a funny thing that happens when we round that guy up. Number 5 is the exact same process, except instead of having the missing side, in number 5 we're given both sides and we're asked to find the angle. So anytime we're asked to find the angle, we need to use the inverse sine function, because our calculators automatically think, oh, they've given me a ratio of sides. In this case, you're telling your calculator to give you the angle instead of the ratio of sides. So that can get a bit tricky. And that is 5. Does that kind of help you out, Alex? Is it a little bit more clear or still confused? Give me a second. Yeah. So this is the learning guide from Unit 8, Abby. Is there anything else from Unit 8? I know a few people are just trying to finish it up. Well, it's out. If not, I'll jump into the exam learning guide, or midterm number 2 learning guide. Let's see anything else coming in. We will go to the review. Final study. Just a reminder, if you haven't had a chance to fill out this little sheet, the topic study guide as I called it, at the bottom of Unit 8. And if you could just go through it real quick, just jot down some answers. You can even do it on the computer if you want. You don't have to print it off and scan it, whatever. If you could just go through it quickly and just let me kind of know where you're at, and then I can, focus the review for next week on the stuff that, people had issues with, and it would just help me a lot. Final review learning guide. We had a bunch of questions. Abby has some exponent questions. That's good. There was some up above. I'm just going to scroll back up here in chat. Could you go over number 1 on page 9 for Ava? Definitely 5, 6, 7, 8, 9. Okay, so a linear system of equations. This is stuff that I guess we've done somewhat recently. Solve the following system by graphing, by substitution, and by elimination, I suppose. So it's asking us to solve the system 3 different ways. It's just kind of a quick way to make sure you get the same answer 3 different times. So the first one's graphing. Ava, was there a particular way that was giving you some issues, or just kind of the whole question in general? I'm going to solve by graphing first because we haven't done one of these in a long time. I'm going to label my equations number 1 and 2, and then I will solve from there. So I'm going to switch to slope-intercept form because that's the easiest for me to plot. You could find the x and y intercepts of each of these lines and plot them that way as well, but I'm thinking going slope-intercept form is going to be the easiest. So I'm going to take equation number 1, 12x minus 3y is 6. I'm going to try to get y by itself. So what I'm going to do is add 3y to both sides. Because it's negative on the left, I'm going to move it to the right to make it positive. So I have 12x equals 6 plus 3y. I'm going to subtract 6 from both sides. So I have 12x minus 6 is 3y. And then I'm going to divide both sides, or I should say each term, by 3. And that's going to give me just y on the right. 12 divided by 3 is 4. So 4x, 6 divided by 3 is 2. And I end up with y is 4x minus 2. So that's in slope-intercept form. And I'm going to do the same thing with equation number 2, which is already in slope-intercept form, which is nice. 4x plus 6. So I don't even need to change that. All right, so let's plot equation number 1. I'll do equation 1 in red. So my y-intercept's -2, so -1, -2. And my slope is 4, which is the same thing as 4 over 1. So I'm going to go up 1, 2, 3, 4, and I'm going to go to the right 1. I think I have a ruler in here somewhere. There it is. All right, so I'm going to try to draw a line as carefully as I can because I'm trying to figure out where these two lines are going to intersect. And I want to do that as accurately as possible. The second one's already done. The y-intercept's plus 6. So that's my y-intercept. And the slope is -4, and that could be -4 over 1. So I'm going to go down 4 because it's negative. 1, 2, 3, 4, and over 1. And it's kind of convenient that that second, or the slope point actually is a shared point between the two lines. So it makes life a little bit easier for us. All right, I need to identify where these two things cross. So that's fairly obvious here. That looks like it's at x is 1, y is 2. If I'm not mistaken. So I'm thinking that's the solution. The question also asks us to do it by substitution and by elimination. So I'm just going to scroll over to the right here a bit, and I'll do substitution next. So what I'm going to do is I'm going to put equation number 2 into equation number 1. So equation number 1 was 12x minus 3. And because equation number 2 is already solved for y, I can just plug it right in. Maybe I'll switch colors just so we can see what I've done. So -4x plus 6. So that's what y is equal to. 3y, and that is equal to... All right, so I have substituted equation number 2 into equation number 1. And now I need to expand, combine like terms, so kind of follow my BEDMAS rules and go from there. So I have 12x. I'm going to multiply this by each of these. So 3 times 4 is going to give me positive 12x. And then 3 times 6 is going to give me negative 18 is equal to 6. It's 24x minus 18 is 6. And I only have x's left, so I'm going to try to get x by itself. So I have 24x is equal to 24. I divide by 24 both sides. And I end up with x is equal to 1, which is kind of the first step of 2, I guess. Once I've figured out what x is, now I need to go back and figure out what y is. And I can substitute this into either of the equations, 1 or 2. I kind of like the look of equation number 2 because it's y equals already. So if I plug this in for x into the second equation, then I already have y by itself, and it'll maybe be a little bit easier. So let's do that. I have y is equal to -4 times 1 plus 6. Y is equal to -4 plus 6, which is equal to positive 2. So I have x is equal to 1 and y is equal to 2, which is the same thing I had from my graph. And Avery, I would agree with you on the whole substitution more than elimination. I guess when you're on a provincial exam, unless they are asking you to identify an error in a bunch of steps, if it says solve the system, then you can use whatever method you want. I find substitutions usually a bit more algebra. Sometimes it's more work, but kind of easier, I guess. Less spots to make mistakes. I'm going to go even further to the right, and we're going to try solving by elimination, which in this question might be a bit tricky, but we'll see if we can figure it out. All right, so I just need to make sure I get these both written down properly. 12x minus 3y is 6, and y is equal to negative 4x plus 6. Now, in order to solve by elimination, we need to have either an x or a y that's the same. So when I line these things up kind of vertically when you're adding or subtracting, that one of them will get eliminated. I can add or subtract the equations. I don't have to always add. I can subtract sometimes. So what I should probably do is get the equations so they're both, I don't want to call it place value because that's not really making sense here, but if the x's and the y's are on top of one another in terms of my equations. So I'm going to take this first one. I'm going to go 12x minus 3y minus 6 is equal to 0. So I just move the 6 over. And for the second one, I'm going to move everything to the left as well. So I'm going to get 4x plus y minus 6 is equal to 0. So I've just rearranged both of those equations. Now I need to think, I need to either get my x's or y's the same. And just by quickly looking at it, I mean, there's no right way to do it. You can do whatever way you want. But I see that I have a negative y here and a positive y. So those are already different signs. So if I were to add those together, I could possibly eliminate them. But I have 3 y's on the first equation and I only have 1 y in the second. So I'm going to need to get a 3 here. So I'm going to multiply everything in this second equation by 3. So I'm going to rewrite my first equation, 12x minus 3y minus 6 is 0. And then I'm going to have, keep losing my y's, 3y minus 6. So there's my first equation, just rewritten. Now my second equation, I'm going to multiply everything by 3. So I'm going to get 4 times 3 is 12x plus 3y. 3 times 6 is negative 18 equals 0. And I am going to add these two equations together because by eliminating the y, I get rid of one of my variables. And then I can just solve for x. So adding these things together, 12 and 12 gives me 24. These guys go away, so I have 0y. I don't need to write it, but I did. Minus 24 is 0. And then you go 24x. I'm going to add 24 to both sides. I'm trying to get x by itself. So 24 is equal to 24. Divide both sides by 24. And I end up with x is equal to 1. And then it's the same process as I did right here where I substituted it in, and I get y is equal to 2. And that gives me the same answer 3 ways, which means that I did everything correctly. Now, I guess the tricky part with elimination in this particular question is the fact that when I look at my original 2 equations here, they weren't in the same order. So I had to first rearrange them. After I rearranged them, I needed to get some coefficient in front of my x or my y to be the same. So I needed to multiply everything in the second equation by 3. So before I've even done elimination, I have 2 steps. So if I were given an option, if I were just given these 2 equations and I didn't know which way it wanted me to solve them, I would probably just automatically go to substitution because that second equation was already solved for y. So in this particular example, it makes the most sense to go with the substitution. Graphing worked out pretty easy as well, which was perhaps just a coincidence, I don't know. But yeah, elimination with the two equations that we were given doesn't really make as much sense. It's just a lot more work. But if you really like elimination, then you can use it. Pardon me. All right, so I'm sure we'll have time, Abby, to go through some of those exponent questions. All right. We can look on to the next question. So we did number 1 on page 9. We went over 4 and 5. And then page 2, 4a. So I can scroll back up to that. Page 3, 2, 4a. Maybe it was a sign issue, formatting type deal. Just combining like terms. So the kind of easiest way for me to describe this question is, if you're looking at it and you're like, oh, these radicals, I get so confused. Maybe just think of like, I don't know, if I gave you a question, most students in grade 10, if I said 3x plus 4y minus 6x plus y, most students would look at something like that and be like, oh, that's pretty straightforward. I have 3x's here, I'm subtracting 6, and then I have 4y's and y here, so I'm going to just, end up with negative 3x, and then 4y and y is going to give me 5y. You could probably end up with that. Now the rules, oh, sorry, Taylor. The rules are the same for the radicals. If I have these radicals, then I can just treat them the exact same way. So was it a different question, Taylor? A different page or something like that? You made a mistake. I have a feeling there's something there that you need to go over. 4 and 5, traveling 2, 4a, yes, sorry, it's late learning guide. Unit 8, I don't need 4a. Okay, it's page 5, 2b. And then we'll get to some exponent ones for Abby. So page 5, 2b, 3, 4, 5, 2b. Okay. We're good with that one? That's the one you're thinking there? Sorry, I didn't see you correct that, Taylor. This is going to be just kind of above it, page 2, 3D. Okay. Do you still need this one here on page 5? Page 5, number 1B. I'm getting all confused now. Learning guide, can't find it. 5, 2B. Oh, I'm on the wrong question again. A factoring type question. Page 2, 3D. I've confused myself and you and everyone else, I think. I'm going to go with page 5, 2B because it's a good question involving factoring. And factoring is worth going over. Substitution, more elimination. Okay, cool. Let's look at it. First thing I do for any factoring question, doesn't matter what type of question it is, if I have a binomial, trinomial, monomial, I need to look at it and say, are there any common factors between my terms? And in this case, there is. I can't pull an x or a y out of all 3 of my terms, but it looks like a 2 is common to everything, so I'm going to pull that out. So I'm going to factor out a 2 and ask myself, okay, what's left if I pull out a 2? Remember, factoring is just the opposite of multiplication. So my first term here is 2x squared. If I divide it by 2, I'm left with x squared. My second term was 16xy. If I pull out a 2, I'm left with 8. And my last one is going to be 15, because 30 divided by 2 is 15. And remember, if I were to work backwards, I would just multiply. So if I were to multiply this 2 through the bracket, would I end up with what I started with? Would I end up here? And in this case, I would. So I know that I'm doing it correctly. I'm going to kind of do the longer. Yes, Alex, you're right. I was monomial is 1. How do you find a common multiple with only one number? It doesn't make any sense. So we have to have at least 2. From here, I can figure out numbers that multiply to 15 and then add to my middle term. So I guess I can call it my magic number. My magic number is 15. What are the factors of 15? Specifically add to -8. So I could have 1 times 15. I could have -1 times -15. I could have 3 times 5 and -3 times -5. I'm thinking those are all of the factors of 15. 3, 5, 1, 15, yeah. Now I need to figure out the set of these that multiplies to 15 and adds to my middle term, in this case -8. And if I have -3 plus -5, that gives me -8. So 3 and 5 are my common or my special ones that I want to use. Now, in a question like this, if we know, because there's nothing in front of the x squared term, I can just simply say, okay, it's -3 and 5, and just write down those as factors, and I'd be done. But I'm going to do it the long way, because the long way will work for any factoring question. So I'm going to just bring this 2 down for the ride. I'm going to have my x squared here, and I'm going to break my middle term up into the 2 factors I had. So I had 8xy, and I'm going to break it up into -3xy, and I'm going to have -5xy. And then this 15y squared, again, is just coming along for the ride. So all I've done is I've established what I needed to break that 8 into to make this whole thing work out. Just getting to your question here, Taylor. So you always have to pull a number out of the equation first. Yeah, if there's anything that's common to all 3, you pull it out, it makes your life easier. You still will be able to factor it if you haven't pulled it out. It'll just eventually come out at the end. So you might as well get it out at the beginning, because it's just going to make everything easier along the way. And Avery, yeah, we haven't done this stuff since the very beginning of the second term, so it's been a while, definitely. All right, once I've done that, I'm going to kind of split my question into 2 parts here, and then I'm going to look for any common terms. So maybe I'll go square bracket now, not to confuse my brackets. Anything common between the x squared and the 3xy, it looks like I can pull out an x. What am I left with? I'd be left with an x and 3y. All right, my second 2 terms. Now I know I need to end up with x minus 3y here, else this whole factoring thing didn't work. So what do I need to pull out of these 2 to end up with an x minus 3y? I need to pull out a -5y. Now it's a little bit tricky thinking of that. You know what, I'm just going to drop this down a little bit so we can see it. -5 x minus 3y, and close my square bracket there. So if I were to multiply this 5 through 5y, I would end up with what I had up here. And if I were to multiply this, I would end up with what I had up here. So this is why I always say, oh, factoring can get really hard. There's tons of different sort of things going on here. And it's important that you understand what's happening. All right, so I have this 2 just hanging out on the outside. Both of my halves have this x minus 3y, so I'm going to pull it out. And then what am I left with in the first half? Well, I'm left with this x, and I'm left with the minus 5y. So I have x minus 5y. Now I can lose these square brackets, and that is my answer. So when I kind of quickly went through this whole learning guide, I said, you know, there's 2 factoring questions here, and they won't cover all of the things that can happen in factoring. These aren't even the complex factoring questions that have a number in front of the x squared term to begin with. So this isn't a good review of factoring. This is just a factoring question. There are lots and lots of factoring type questions that you can run into that will look very different than this. So, I mean, there's not going to be a ton of factoring questions on the exam, but factoring is a really important idea in math that you'll use again in grade 11 and 12. And if you move on any further, you'll continue to use this factoring. So there you go. New idea for Math 10. That's why it's kind of an important one that we kind of stress a lot, and you definitely use it again and again and again. So, Taylor, did I get through your question? I think you might have asked another one. Need 5, 2b, and page 2, 3d. I think I got those. Factoring makes no sense. This should be illegal. Expanding is way better. Well, I mean, it's just opposites, right? We go forward, we're factoring. We go backwards, we're multiplying. It is what it is. I can go over number 4 on page 2 for sure. I know that Abby wanted a couple exponent law questions, or maybe one. I'll go through some exponent law stuff first, and then I'll get to that one. Page 2, 3D. Cool. I'll jump back up to that one in a second here, Taylor. I'm going to find some exponent questions. Now, of course, all of my exponent questions are formatting incorrectly. Was there anything specific here, Abby, that you had your eye on? I can pick anything, or I can pick one that you maybe had some difficulty with. I'm liking the look of C. It's got a lot going on. Didn't format correctly, though. Maybe the first or second ones. Okay, those are really easy ones. But I guess they have the same sort of laws. You know what? I'm gonna see if I can get C here. Think about how to do this. I'm gonna just jump into the course, and I think it's formatting properly when I download it. It's just when I bring it into OneNote that it's not working. So this is the final exam review package. Here's the assignment. Oh, it's not formatting properly in here either. X, Y, -8. Maybe I'll do like B and D. It's both division. That's not working out either. It's just a bunch of gibberish. Yeah, mine clearly is doing the exact same thing, Taylor. So if you're running into issues like that, then just obviously don't worry about it. Jump back in here. Let's look at B. So when we are thinking about our exponents, we need to remember our exponent laws. So if I'm dividing something, if I have x to the power of a, where a is some number, and I'm dividing it by x to the power of b, what am I going to end up doing? Well, I'm going to go a minus b. So when I'm dividing, I subtract. When I'm multiplying, x to some a times, let's use that, times x to the b, I'm going to add my exponents, a plus b. And then I can kind of just think of my numbers out front here and just deal with my numbers individually. So if I like to just cross things off when I divide, actually. So I'm going to do that. 14 divided by 7 is going to give me a 2 and a 1. If I simplified it, 7 goes into 14 2 times, 7 goes into 7 once. So that kind of gets rid of those. If I look at my x's, if I subtract, or I think, okay, I have 7 x's on the top, I have 2 on the bottom. My x's on the bottom are all going to go away, and I'm going to end up with 5 on the top. And same here, y to the 12 minus 10, I'm going to end up with 2, and my 10 are all going to go away. So everything on the bottom just ends up being 1, which is kind of interesting. And then I'm left with 2. I'm left with 5 x's on the top and 2 y's. So I want to subtract with the multiplying, yeah. For letter A here, for instance, I think that's the only multiplication one. When I multiply, I need to add my exponents. So when I have numbers in front, like 4 and 3, I just multiply those like I regularly would. And remember, if I have things in brackets, it's implied that there's multiplication between these two things. You guys know that. So the 4 and the 3 together gives me 12, and it's a negative 4, so I have negative 12. And then I have my x's. So my first one here had a 2, and then I'm going to add to it a 3. And then my y's, I started with 5, and I'm going to add to it a 2. So I'm going to kind of simplify this. Negative 12x to the 2 plus 3 is 5, and 5 plus 2 is 7. And that's all I can do with that. With something like letter D, we have this exponent outside of the brackets here. I'll do D as well because I know this can get tricky. 3a to the power 4, and then negative 3, and then a to the 7. Why don't we have to multiply everything by everything else? You're thinking like, not sure what you're thinking. Like the x squared by the like y squared in the first one here. So why do we not multiply something like this y by this x? Yeah, the difference between something, I think Avery, you got it on the head here. So with something like FOIL, what we have when we were foiling is two binomials. So we'd have like x plus 2, and then 4x minus 3y or something like that. You'll notice when we have the FOIL situation, we have addition and subtraction here in the middle. The question that we're dealing with, or we're given here in letter A, we don't have any addition or subtraction inside of those brackets. So when we're multiplying, because there's no addition or subtraction there, we don't have to deal with it that way. What we're just doing is, because everything in this first term here is multiplied by everything else, and then everything in this second term is multiplied by everything else. It's just as simple as we can get it. It's 3 times x cubed times y squared. I can't simplify this 3x squared or x cubed y squared any further. That's as simple as it gets. So I guess it might just be a matter of getting it kind of organized in your head that if I don't have any addition or subtraction to deal with there, then I'm just multiplying everything together. I don't know what the easy way to sort that out is for you, Abby. I think it's just something you're going to have to come to terms with. For letter D, I like this one, so I'm going to do it. I have an exponent on the outside, so both things in here need to get my exponent. So I'm going to have 3 to the negative 3. I'm going to have a to the 4 times negative 3. And then on the bottom I have a to the 7. So because we have our exponent outside a bracket, we have to multiply our exponents. So I have 3 to the negative 3 still. I have a to the 4 times negative 3, which is a to the negative 12. And then on the bottom, I have a to the 7. So I guess there's a couple ways I can go from this point. I can think, okay, I have a negative exponent, so it needs to go to the bottom. Or I can say, okay, I have negative 12, and then I'm subtracting 7 because I'm dividing, which is going to give me negative 12 and 7 is negative 19. So because it's negative 19, then it needs to go to the bottom. Both sort of things will end up in the same spot. So I have 3 to the negative 3. I'm going to move my a to the 12 to the bottom to make it positive. And now I have 2 positive exponents on the bottom, so I'm going to add them together. So I still have this 3 to the negative 3 on the top. I have a to the 12 plus 7 is 19. I need to get rid of this negative exponent, so I'm going to move it to the bottom. Now I don't have anything on the top, so what's really there? Well, I just have a 1. And then I have 3 to the 3, a to the 19. Kind of weird how some of these exponent questions work out. But there you have it. So just remembering the exponent laws is kind of half the battle here with these types of questions. You need to, remember when I have an exponent on the outside of a bracket, I need to multiply. When I'm, multiplying exponents, I add. When I'm dividing, I subtract. If I have a negative exponent, I can move it to the bottom, it becomes positive. And then we dealt with fractional exponents. So each individual exponent law by itself, really straightforward. But when you put them all in one question, it gets kind of confusing and complex. So Avery, yeah, could we multiply the 3 to the 3 to get the 27? We could. Some questions will leave it as 3 to the 3, but sometimes you'll see answers as you might see it written like this as well. 1 over 27, a to the 19. There you go. Thanks, Taylor. So yeah, it's kind of just depends on what the answer looks like. It's not super consistent. I mean, your provincial exam could have either or, and you should be able to recognize that those are the same thing. Obviously, Avery, you did. Okay, so Abby, is that good for exponent laws and everyone else for that matter? I know you were kind of stuck on the first one there, and I think you might have it straight in your head now. And then a few other people were asking about them, so good there. I think Taylor had one other question from a page above. I'll go back to that for sure. Avery is asking about exponent stuff. So while I'm in the exponent section, I can talk about that. Let's just bring this up. Can you do a quick example of putting a radical in its simplest form, because I always get confused about what is the simplest. Radical in its simplest form. Are we talking about exponents, like radicals as exponents and then converting back and forth? Or are you talking about simplifying like fractional, or are you just simple radicals? Like if I had the square root of 50, how to simplify that? Are we talking about that? Or are we talking about like 50 to the 1/2 and 7 to the 3/4? Are we talking like that, or just root 50, like square root of 50? Okay, cool. All right, so let's just, I think square root of 50 is a good enough example. There's a perfect square I can get out of there. So if I am looking at the square root of 50 and I'm asked to simplify, I'm sure there's probably questions on this review that look like this, but that was just the first one that popped into my head, so we'll just go with it. So simplifying is there any perfect squares that go into 50? I mean, 50, if I were to bring out my calculator here and I were to do the square root of 50, that's going to give me, 7.07. So obviously the square root of 50 isn't a perfect square. But I can simplify it a little bit, and that's what I'm going to do. So I need to ask, are there any perfect squares that we can pull out of 50? Is there anything that can divide into 50? And this is where knowing your perfect squares is really important. So if I think of, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, all the way up to probably you should have it all the way to 11 or even 12, like 144. So I'm thinking that I can definitely see that 25 is going to go into 50. So I'm going to break my 50 down into 25 multiplied by 2, because 25 times 2 gives me 50. And I know when I multiply radicals, I can just multiply whatever's under each radical. So if I were to work backwards, I could just write this line here as the line above it. Now, why did I pick 25? Well, on my calculator, if I take the square root of 25, that just gives me 5. So I picked 25 because it has a perfect square, and I can just pull the 5 out. So instead of writing it as square root of 25, I can write that as 5. Those are equivalent things. In my calculator, the square root of 25 is 5, and I can just write it like that. The root 2, I can't simplify any further. So that is as simple as it gets. Now, I guess I can write it as 5 root 2 or root 50. So let's maybe take a look at what that looks like. So if I go square root of 50, it's going to give me a decimal, 7.0716. Okay, so if I put 2 times the square root of 5 times the square root of 2 into my calculator, I should get the same number, shouldn't I? Hopefully. And if I do press it, I do end up with the same number. So the square root of 50 is 7.0716, goes on forever, and 5 times the square root of 2 gives me the same number. They are equivalent. I've just written the same thing 2 different ways, simplifying it, pulling out the biggest perfect square I could out of it. And that is kind of, I guess, the main idea we're talking about there is, are there any perfect squares that go into that thing? Now, that's a really simple question. On a test, you're likely to see something like, we have the square root of 18 plus, 2 times the square root of 50 plus root 36, where you have to do it, simplify this, simplify this, simplify this. You're going to have to do it more than one time and then combine like terms. But that's kind of how we're going to end up getting that answer. Hopefully that helped. If it didn't, ask another one and I can do a few more. We have lots of time today. I think Taylor had one question that I haven't got to yet. Where is it? Source to this think boom, bang, bang. Can you do that? Page 2, 3D. I think that's the one. Page 2 and 3. There's 3D. Okay. That is a good one. And I think that's, I used the wrong mouse. Page 2, 3D is kind of what we were just talking about as well. Same sort of idea. All right. So it reminds me of the question on that provincial exam I was going through last day with the square root of 360. Okay. I'll just move this up here because I'm going to need some room. 360 m cubed. Okay, I have a couple things going on. I have a variable under my radical sign, and I need to, simplify that. I also have this 360, which I need to deal with. And then I have this 3 out front, which I'm just going to leave out there just going to always kind of come along for the ride. So I'm going to deal with the 360 first. Can I simplify that? Is there anything that goes in there? So getting back to the same idea. Simplifying the 360. Are there any perfect squares that go into 360? So I think, 36, that's a perfect square. 36 times 10. How do I know just to go to 36? Well, it's just, kind of experience and practice. The more you look at these types of questions, the more the perfect squares kind of jump out at you. So I have this 3 out front. I'm going to break this up into square root of 36 and the square root of 10 times m cubed. I know what the square root of 36 is. I picked 36 because it was a perfect square. It gave me 6. And then 3 times 6 gives me 18 times m cubed. So I've simplified the number. I can't, pull out any perfect squares out of 10. The smallest perfect square is going to be 4, and 4 doesn't go into 10 an integer number of times. And then I have 9. 9 doesn't go in there either. So that doesn't work. So 10 is as simple as it's going to get. The last thing I need to deal with is the m cubed. And maybe I'll just do this on the side here. If I have m cubed and it's under a radical sign, that's kind of like saying, what is the square root of m cubed? So this is m to the power of 3 over 2. Flower's the power, root's the root. If I had m squared over 2 and m to the power of 1 over 2, I could just change this to m to the 1 and m to the 1 over 2. This is where it gets kind of confusing. Now, in the course, it just said, how many powers of can you get it to just m squared? So if I had m squared, the square root of m squared is just going to give me m. The square root of anything squared is just going to give me whatever it is. So the way that the course talked about it, and I didn't really do a great job of this, I'll admit, we'll go m squared times m to the power of 1, or just m. I'm going to break it up into squareds. So the more, if I had something like m to the square root of m to the 6, well, I could just say, okay, that's m squared times m squared times m squared, and I would just end up with m times m times m, which is going to be m cubed. So the square root of m to the 6 is m cubed. I guess what I'm getting at here is that the square root of m squared is just going to give me m, so I can now pull it out of the radical. So I'm left with 10m. So exponents under radical signs, if you can get it to a squared, then that means you can pull it out. And remember, when I have exponents and I'm multiplying them, I can just add them. So that the 2 here and the 1 together gives me what I had above, which was the 3. These don't come up a lot, but I guess they can. The exponents part, okay, I guess I'll go with the m to the 6 that I had here. So if I had the square root of m to the power of 6, I could write that as m to the power of 6 over 2. Are we all right with that? Okay, what is 6 divided by 2? Well, that's just m to the power of 3. So the square root of m to the 6 is equal to m to the 3. I'm happy with that because it's an even number, it works out nicely. What if I had an odd number like m to the power of 3? Let's look at this m to the 6 again. I could write that as the square root of m squared times m squared times m squared. What is the square root of anything squared? Well, it's just itself. So this would be m times m times m, which is m cubed, which is what I had up here. Now I have the same thing here. So when I have even numbers, it works out nicely, but when I have an odd number, I run into problems. Let's go the square root of x to the 7. Now I can rewrite this as x to the 7 over 2, but 7 isn't divisible by 2, so I don't end up with some nice happy number. So what I can do is say, okay, I can write this x to the 7 as x to the 2 times x to the 2 times x to the 2. There's 6 times x. Now I know if I write these things individually, the square root of x squared, square root of x squared, square root of x squared, square root of x, the square root of x squared is just going to give me x. This is going to give me x. This is going to give me x. And I can't do anything here. So I'm going to get x to the cubed times the square root of x. So the square root of x to the 7 is going to be x cubed times x. I didn't spend a lot of time on it in class because I didn't really think it was that important. And it has come up a few times in the learning guides, but I don't really recall seeing it on provincial exams often. So it is what it is. If you kind of get it, awesome. If you're struggling with it, then not the end of the world. I think that was it for Taylor's question. I did it and another. Is there anything else from this learning guide that we're having issues with? Any topics just in general? Any questions you were struggling with? Obviously, we don't have class tomorrow because it's Friday and everyone's going to come cross-country skiing. When we were cross-country skiing, we were on this trail and there's this big hill that we were about to go down, and we were kind of just waiting because these two trails merged. And there's this man skiing on this lower trail. And I was standing next to the instructor and I said, "The guy looks kind of a little bit older. How old do you think he is?" And the instructor said, "Oh, he's in his 80s. I kid you not, there was a man in his 80s just, out for a nice leisurely cross-country ski. So if you're worried that it's like going to be too difficult for you, if somebody in their 80s can do it, you can do it. We're going to have a bunch of different groups of people, different skill levels. Well, if you want to go race around, you can do that with Mr. Fender. And if you want to just dawdle, maybe you can come with me. And, if you can make a go of it, it's really fun, and all ages can do it. And Mrs. Ward and Mrs. Wood take their kids cross-country skiing, and they're, I think, 6 and 7. And then there was this 80-plus-year-old man doing it. So it's great even to just get outside for a little bit, even if you only do one run. Be fun. That's my little cross-country skiing rant for the day. Schoolwork, dance practice. Schoolwork can wait. The slope of the hill. That would have been great. We should do that. We could get measuring tapes and clinometers. That'd be fun. Don't give me any ideas, Avery, because I will do it. Make you guys go to Telemark and calculate the steepness of the hills. 4D on page 2. I think we're on page 2. 4D. Okay. So before I do anything on this question, I want to simplify my radicals because it's going to make my life easier. So I'll start with the top. I have the 8. I'm just going to leave it as 8. Are there any perfect squares that go into 20? Well, 20 is going to be 4 times 5. And on the bottom, 16. 16 is a perfect square, is it not? I think 4 times 4 is 16, so I can take the square root of 16 and get 4. Yeah, makes sense. So on the top I have 8. The square root of 4 is going to give me 8 times 2, root 5. And on the bottom, I have 16 times 4. 16 times 4, is that 64? It is 64. So on the top, I have 16, root 5. On the bottom, I have 64. Now, is there anything common between 16 and 64? Yeah, 16 goes into 16 once. 16 goes into 64 4 times. So I end up with root 5 over 4. And root 5 has no perfect squares that will divide into it an integer number of times. So I'm just going to leave it as root 5. I can't simplify it any further. I have this 4 on the bottom. There's nothing I can do about that. So I'm just going to leave it like that. I like the sound of this unschooling. I guess it's kind of maybe like project-based learning, getting out and experiencing it and finding applications of math and things like that. That's good. Maybe we'll do some of that. Moving forward, not in math, but maybe like science or something. Anything else you had questions about? It's an extreme version of homeschooling. There are programs, there's one in Vernon where students, it's like an outdoor academy, so they do things like cross-country skiing, climbing, and then when they're out in the wilderness rock climbing or something, the teacher will be like, okay, we're going to write an English essay about the view from here, the process of learning how to rock climb, and everything's kind of built on this outdoor sort of kind of adventure activities. I don't know if it exists anymore. I think it might have closed down, but it ran for a long time. And you do your English out in the wilderness, and then science, you'd be like, okay, we're going to talk about ecosystems today, and you'd look at the trees and how they die, and then the decomposers eat it and turns it to dirt, and then you can talk about nutrient cycles being like outside. So it was a really, really cool program. More programs are starting to develop like that, especially in the States, but we don't have anything like that, unfortunately, here, because I would love to teach in a school like that. It'd be a lot of fun. Nobody has any additional questions? We have a few minutes left, maybe like 10. If nobody has questions, I might just call her a day. I will remind you guys, all the few of you that are here, that we will be Monday morning, 9 o'clock. We have this math kind of final exam midterm. So make sure you're there, Central Gym. Show up a few minutes early, like 5 to 9 or whatever will be fine. And you can do that. The exam, I'm almost finished. It's going to be 35 questions multiple choice. And then I think we're going to do 5 questions written. So that's going to kind of be the exam. So the multiple choice, it'll be just like the last time. Yeah, you can bring your learning guide in, so you don't need to upload it and submit it. If you don't want to, if you just bring it in with you and give it to me, I can just look at it real quick while we're at the exam on Monday morning. And yeah, it's 35 questions. I think 30 of the questions are from chapters 5, 6, 7, and 8. And then there's about 5 questions that are from the first 4 chapters. So I think everything's there. I will have a formula sheet for you. I will have the test printed out for you. You will only need to bring yourself, an implement to write with, and a calculator. And Taylor, yep, I will email that password for the online version to your mom, Taylor, so you can write it down the coast. Avery, that sounds really cool. I know KSS has something similar. They have an outdoor ed class, and they do things like that. They'll go snow caving in the winter and canoeing in the summer and stuff. So there are some pretty interesting electives. I think we try to, kind of emulate that with our Friday activities. We give you a broad variety of things like fencing and archery and, go to cross-country ski. So we're trying to give you exposure to a lot of things. I think we do some badminton coming up next. I love badminton so much. Such a fun game. Are there any other questions before we end for the day? Alex is happy about either the weekend or the midterm coming up. He's very excited. Very excited. I'll have everything for you. Just show up, bring the learning guide if you have it done. If you want to submit it online, that's fine. I won't see you. Hopefully I see you tomorrow, though, for skiing. Mystery school, where you school around, what you enjoy. Yeah, that'd be cool. Field trips so good with this program. I do like the field trips. I do enjoy getting outside on Fridays, even if it's just out of the school into a building. Alex is asking, do we have English or ADC planning next? I'm not sure. Let's go check the front page of the course. See what it says. January 11th to 15th. Today is the 14th. It looks like you have nothing. Did I see that correctly? 11, math, 9, 10, 20. Yeah, I guess you just need to continue. Oh, I'm standing in front of it. There we go. Thank you, Mr. Ross. Right, so it looks like, yeah, there's nothing. So I think what Mrs. Wood said yesterday was, if you have ADC assignments to submit, get them in. If you have any English assignments to submit, get them done. If not, I would recommend spending the next few minutes to maybe continue finishing off your learning guide, or you could go over the provincial exam that I gave you. I mean, you've set aside this time in the morning, you might as well use it to get some schoolwork done, whatever that may be. So that's it. I have a couple minutes just to kill. So next week, we are having our midterm on Monday. I'll finish going through the exam that I started last day. I'll finish going over that on Tuesday and Wednesday. It only leaves 3 more classes before the end. And then you guys are ready to write your provincial. So if you're having issues with any questions and you need to, ask questions or whatnot, just write me an email. We can find time to meet next week or whatnot. I want to make sure you guys have everything under control going into this provincial exam. So if you're running into issues even next week, at the end of the week, just send me an email and we can go from there. When do we start science? That's a good question. I think we start on February, let's bring up my little calendar here. Probably the provincial exam week is 25, 26, 27, 28, and then 29 is the official start of term 2 or semester 2. I don't know when we're going to start classes. Maybe the Monday the 1st of February. So that's when we're going to start science. Do we have any classes exam week? No, Abby, you don't have any classes on exam week. I'm going to make myself available. Well, this little slide comes up behind me here. This is what exam week looks like. So you have your English exam on Tuesday. You have my Math 10 exam on Wednesday afternoon. I'll make myself available on Monday and Tuesday maybe if you have any questions, stuff that needs to be looked at. But yeah, you don't have class at all that week. We are going to go cross-country skiing again on the 29th as kind of a wrap-up for January. And that's kind of it. So that's what the next couple weeks look like. Heck, that's looking forward 3 weeks. That's a long time into the future. I don't even know what I'm having for dinner tonight, let alone 3 weeks from now, but that's kind of what we have. So if I don't see you tomorrow, you guys have been doing so well on these tests. Don't stress out about this midterm on Monday. It's going to be really similar to the one we did before. Just show up, write the test, do your best. You guys are going to do great. And then we'll just kind of focus on reviewing things you need to learn. And there you go. That's a good idea, Alex. Chicken Caesar. I like chicken Caesar. So everyone, have a great weekend. And we will see you bright and early Monday morning, live and in person, Central Gym, 9 a.m. Goodbye.